Hi everyone, I'm Sleepless Scientist, and tonight we're starting right at the burning, breathing, musical heart of our cosmic neighborhood, the Sun. No, really. It sings. Not in soprano or jazz, but in waves, deep, low, slow pulses that ripple across the solar system like the universe's own heartbeat. You just can't hear it because your ears weren't designed for that kind of concert. Imagine you're floating in space, orbiting just outside the Sun's raging atmosphere. There's no sound out here, space doesn't carry it. But if your body could somehow feel vibrations instead, you'd be shaking like a tuning fork. The Sun vibrates constantly, murmuring its fusion-powered melody through seismic waves known as helioseismic oscillations. And scientists, they actually listen to it using satellites and computer models. So yes, there are people out there who spend their entire careers eavesdropping on a flaming gas ball. And if you think that's boring, you're probably not doing bedtime science right. Here's your first weight. What fact: the Sun is not solid, not even close, but those vibrations act almost like sound waves through a bell. These waves allow scientists to peek into its hidden interior, its core, convective zone, radiative layer, places we can't see but can kind of hear. It's like echolocation for astronomers. You might think it's relaxing, but no, the Sun doesn't hum like a lullaby. It roars in waves lasting minutes to hours, vibrating across its entire 1.4 million kilometer diameter like a lazy but angry drum. And here's where it gets juicier. These sound waves aren't just cool party tricks. They help us monitor sunquakes. That's right, earthquakes, but on the Sun. Think about it. The Sun throws a tantrum in the form of a massive solar flare, and it literally quakes in protest. You can't slap a seismograph on the surface, so we have to listen from afar, like nervous neighbors listening to the thuds upstairs. Oddly enough, if your ears were attuned to its natural music, the Sun's sounds would still be far too deep for human hearing, way below the range of our audible spectrum. But NASA sped them up like turning up the tempo on a whale song, and guess what? It actually sounds kind of meditative, like a sub-bass ambient techno track composed by an immortal gas giant with no chill. But let's zoom in for a moment. You lying there in your bed are directly powered by this celestial opera singer. Every light bulb, every sandwich you've ever eaten, sunlight, trapped energy, stored songs millions of years old now microwaved into your Pop-Tart. Makes you feel just a little cosmic, doesn't it? Now let's mess with your survival instincts. The Sun is lovely and all, but it will 100% destroy you if you get too close. Like instant skin-melting, bone-vaporizing, oops, I forgot to wear SPF 10,000 kind of destruction. Just standing on Mercury at noon is a full-body toast session. You'd be extra crispy in under 5 seconds. And yet here we are, floating comfortably in Earth's Goldilocks zone, eating cereal and watching cat videos. Scientists still debate how stable the Sun actually is over the long run. Sure, it seems reliable, but it has cycles, 11-year tantrums, sunspot acne, and violent mood swings called coronal mass ejections. Some of them are so powerful they could fry our satellites or knock out the global power grid. Fun bedtime thought, huh? Here's a weird aside for you. Crocodiles are known to sunbathe with their mouths open. Why? Thermoregulation. They're basically the reptile version of solar panels. So in a strange way, you and a crocodile are both using the Sun to survive, except one of you does it with Wi-Fi and iced coffee and the other hisses at flamingos. Perspective. But back to space. While the Sun's radiant light reaches Earth in about 8 minutes, the energy that creates it takes thousands, even millions of years to escape from the core. Imagine shouting inside a dense crowd and having your voice take 1,000,000 years to reach someone. That's what it's like for a photon inside the Sun. It's not a beam of light. It's a prisoner slowly bouncing its way to freedom. And when that light finally bursts into space and hits your skin, that's ancient radiation. Not in the mutate your DNA sense, don't worry, but in the you're catching a sunbeam that's been trying to escape since woolly mammoths were a thing sense. That's wild. So next time you're soaking in a bit of sunlight, on a walk on your balcony through the window during your morning doom-scrolling session, just know you're feeling the relic of a nuclear process that started before humanity even knew how to roast a marshmallow. And that's only scratching the sun's surface. Literally. We haven't even talked about the corona solar wind magnetic field lines, or how solar storms once made telegraph wires catch fire in the 1800s. But let's leave some surprises for later. Now remember this warm, humming, slightly deadly star, because it's going to follow us through the rest of the solar system, like an overbearing cosmic parent, lighting the way, melting the shadows, and occasionally smacking a satellite or two just to keep things interesting. I'd love to know where in the world you're listening from and what time it is for you. Let me know in the comments below. I'm always curious where these quiet little science stories are drifting to, and if this video helped you while you were there. Now relax, take a deep breath, and join me gently on this evening's journey. You drift onward past the flaming concert hall of the sun, and the light starts to stretch. Shadows grow sharper, and the temperature drops like someone left the freezer door open. Welcome to Mercury, a planet that really shouldn't have ice. And yet somehow it does. Mercury is the closest planet to the sun, and yet one of the coldest places in the solar system is right there on its surface. Sounds fake, right? But it's real. Deep in the craters near Mercury's poles where the sun never peaks, there's frozen water. Literal ice. As in the same stuff in your drink, just in a crater that could swallow Manhattan whole. Now let's make something clear. Mercury is a mess. It has no atmosphere to speak of. That means there's nothing to distribute heat. So on one side, you're dealing with oven temperatures that can cook aluminum. On the other side, just a few hundred kilometers away, it's cold enough to flash freeze your eyebrows right off your face. You'd be a human popsicle with third-degree burns at the same time. And yet nestled in the shadowy hollows of craters near its north and south poles, radar from Earth has confirmed reflective material. Scientists believe this is water ice shielded from the sun's heat for billions of years, possibly delivered by comets, possibly created by hydrogen and oxygen reacting in the soil. Either way, Mercury is a desert with hidden glaciers, and Mercury has no tilt. Unlike Earth, it doesn't dance back and forth on an axis. So those crater shadows, they never move. Eternal darkness. It's like someone forgot to install a light switch. And in that darkness, ice. Your brain probably just gave up. Mercury is where your instincts about hot and cold go to die. Scientists still debate just how much ice is buried beneath Mercury's crust. Some think it's just a thin frost. Others suspect deeper ancient layers protected since the beginning. And here's the extra weird part: even though it's water ice, you couldn't drink it. It's likely full of cosmic dust, sulfur compounds, and space gunk that would make a Brita filter cry. You can't talk about Mercury without mentioning its truly unhinged day-night cycle. A day on Mercury lasts about 59 Earth days, but a single solar day sunrise to sunrise is 176 Earth days. That's almost half an Earth year. So if you were standing on Mercury at dawn, you could have your birthday twice before the sun set again. You'd spend so long waiting for evening, you'd forget what the concept of evening even meant. Speaking of which, Mercury has a tail. Not like a comet, but a giant trail of sodium gas that streams behind it like glowing dust. Under ultraviolet light, Mercury looks like it's leaving behind a magical, invisible trail of golden breadcrumbs. Space is weird. Here's a useless fact: in 2006, the Messenger spacecraft confirmed that Mercury shrank. Yeah, As the planet cooled over billions of years, its crust contracted and folded in on itself, forming gigantic cliff-like scarps. Whole mountain ranges just popped into existence as the surface crumpled like a raisin in the sun. So Mercury is the solar system's dried fruit. Add that to your cosmic fruit salad. One thing that gets less attention: Mercury's iron core. It's huge, about 85% of the planet's radius. That's like if Earth were all molten nickel with a little frosting of crust on top. And scientists still aren't sure why it's so oversized. Maybe early impacts blasted off Mercury's outer layers, or maybe it just always wanted to be a metalhead. And yes, despite being so close to the Sun, Mercury still manages to have a magnetic field. Not a great one, but enough to confuse scientists. It's too small, too slow spinning, and too old to technically have one. And yet there it is. Weak, lopsided, and stubbornly pulsing like an old radio station you forgot was still on. If you ever stood on Mercury briefly before vaporizing, you'd see the Sun take up twice the sky it does on Earth. And here's the kicker. The Sun would appear to rise, pause, go backward for a bit, then continue rising. Mercury's orbit is so eccentric that it actually reverses the apparent motion of the Sun in the sky. Space where even the sunrise gets confused. Want one last bizarre tidbit before we drift away? Mercury has been hit so many times by asteroids, it has a crater named Shakespeare, and another called Beethoven. It's like a classical music festival crashed into a rock. Somewhere out there, a scientist had the very specific joy of saying, "Yes, we'll name this hole after Mozart." So now you've met the planet that bakes, freezes, shrinks, vibrates, and leaves a golden trail in the darkness, all without any atmosphere to speak of. Mercury is like your most unpredictable friend, brilliant, mysterious, and 100% guaranteed to leave you both fascinated and exhausted. Time to push off. Let the warmth of the Sun fade behind you. The ice in the shadows stays buried, and ahead, a planet that spins backward, bakes its own clouds, and would probably ghost you in a group chat. But we'll get there soon enough. You drift now to Venus, and right away something feels off. The light's too thick. The air presses against you like hot syrup. And if you could see the sky, it wouldn't be blue, it would be a choking copper-colored haze. But the strangest part, everything's moving the wrong way. Venus spins backward. That's not a joke. If you stood on Venus long enough, which you wouldn't, because your flesh would cook faster than a pizza oven, the Sun would rise in the west and set in the east. Just one more reminder that the universe has no interest in your expectations. Venus doesn't just take its sweet time rotating, it rotates the wrong way. Why scientists still debate this? One theory is that a massive collision early in Venus's formation caused it to flip like a cosmic slap. Another idea suggests gravitational interactions slowly reversed its spin. Whatever the reason, Venus decided to be different, and it's been that way ever since. The rebel planet. The slow spinning queen. And slow it is. A single day on Venus, one full spin on its axis, lasts longer than its year. That's right. Venus takes 243 Earth days to rotate once, but it only takes 225 Earth days to orbit the Sun. So if you lived there, you'd celebrate your birthday before finishing a full planetary twirl. You'd age faster than the planet turns. Time would feel broken. But wait, it gets worse. Venus isn't just spinning backward. It's doing it under the heaviest, thickest atmosphere in the solar system. This thing is intense. 90 times the pressure of Earth's. It's like being 900 meters underwater. If you stood on Venus's surface, your bones would crumble before you could say, "Bad vacation idea." And that's before we talk about the acid. Yes, Venus's clouds are made of sulfuric acid, not metaphorically. Actual acid droplets float in its skies, blowing around in hurricane-force winds. The upper atmosphere is a hellish weather ballet, massive super-rotating jet streams that circle the planet faster than it turns. And below that, a death fog. Hot, choking, sulfur-laced smog. Picture a pressure cooker filled with poison and regret. Here's the kicker: Venus is hotter than Mercury, even though it's farther from the Sun. That's the power of its runaway greenhouse effect. The carbon dioxide in its atmosphere traps heat so effectively that surface temperatures average around 464 degrees, hot enough to melt lead, hotter than any functioning oven. Your flip-flops would vaporize. You want an even stranger fact? The Soviets managed to land a few spacecraft on Venus in the 1970s and 80s, Venera 9 through 14. These machines were built like tanks, and even then they only survived for a few minutes to a couple of hours before they were crushed and cooked. But they did send back haunting color-filtered images of cracked ground and an orange sky. It looks like the inside of a nightmare. And here's the weirdest, most dramatic speculation of them all: scientists believe Venus may have once had oceans. Real ones. Billions of years ago, Venus might have been wet, maybe even Earth-like. Then something tipped the balance. Volcanoes, sunlight, an unlucky atmospheric hiccup. Whatever happened, it spiraled into the planet we know today, a boiling, acid-shrouded tomb. Venus might also be volcanically active right now. In 2023, scientists confirmed surface changes in Magellan spacecraft radar images that likely point to fresh lava flows. It's possible Venus still erupts, still vents gas from the inside, still tries to move and breathe despite the suffocating pressure. A planet with anger issues trying to let off steam. You know what else Venus has? Lightning? Yeah. Thunderstorms in a place with no rain. The atmosphere is so electrically charged it crackles. Imagine acid clouds lit up by constant flashes, like the sky is short-circuiting. That's your view if you ever take a hot air balloon trip through Venus's upper skies, which oddly is the most survivable place on the planet. See, about 50 kilometers above Venus's surface, the pressure and temperature are actually Earth-like. Some scientists have floated ideas about colonizing Venus from above, suspended cities floating on helium balloons. Sounds wild, but compared to standing on the surface, it's practically a spa day. Want a totally irrelevant fun fact? Venus was once the inspiration for many 19th-century love poems. People thought it was Earth's twin. They imagined it as a jungle world, lush and mysterious. Turns out it's more like Earth's evil twin, the one who listens to heavy metal, eats lava for breakfast, and never returns your texts. And yet Venus is mesmerizing. It reflects more sunlight than any other planet. It's the third brightest object in our sky, after the sun and moon. When you see the evening star twinkling at dusk, that's Venus glowing like a diamond with a deadly secret. Venus has no moons, no rings. It's just herself. Fierce, hostile, silent. She moves against the current of the solar system, wrapped in a shroud of acid and heat, spinning slowly through storms. And as you drift past her, watching that heavy air swirl like boiling cream, you begin to understand she's not just another planet. She's a cautionary tale. A cosmic what if. What if Earth had taken a different path? What if our own atmosphere had tipped a few degrees too far? You leave her behind, wrapped in silence, and set your course for a red world that's dusty, dead, and hiding secrets taller than anything Earth has ever built. Mars rises ahead like an ember in the night, cold and dusty, yet tinged with a deceptive warmth. It's the color of rusted iron, the kind of red that makes you think of campfires and clay pots. But this world is no cozy campfire. It's cold, it's dry, and it houses the tallest volcano in the solar system, a mountain so massive it breaks the rules of planetary architecture. Olympus Mons. Even the name sounds ridiculous, like something scribbled into a fantasy map. But it's real, 72,000 feet tall. That's nearly 3 times the height of Mount Everest, and it's so wide that if you stood at its base, the curve of the planet would hide the summit from view. Olympus Mons is a volcano the size of France. Yeah, you'd need a week-long road trip just to drive around it, and that's if Martian rental cars existed. But don't worry, you wouldn't need ropes or oxygen tanks. The slopes are gentle, only a few degrees of incline. This beast isn't steep, just big. Like it rose slowly, patiently from countless lava flows piling on top of each other over millions of years. And here's the kicker, it's probably still not extinct. Scientists still debate whether Olympus Mons might burp back to life someday. It's dormant, sure, but it's Mars. Nothing ever really stays dead here. Which brings us to something strange. Despite its towering volcanoes and sprawling canyons, Mars is a quiet world. The air is thin, just 1% of Earth's atmospheric pressure, and composed mostly of carbon dioxide. That means no breathable air, barely any sound, and forget water. Most of it is locked away in ice or trapped beneath the surface. It's a desert with stage fright, and yet, it's the most Earth-like planet we've found. Mars has seasons, polar ice caps, weather, even dust storms that can span the whole planet, turning the sky tan and muting the sun for weeks. If Earth throws tantrums, Mars broods in silence under a haze of iron and wind. Still, it's a place with a past. Billions of years ago, rivers once carved its surface. We see the dried-up valleys and ancient deltas in satellite images. There were lakes, maybe oceans, maybe rain, maybe life, maybe Mars was once alive. And that's the obsession. NASA, ESA, China, everyone's digging in, sending robots with arms and drills and little weather stations, all hunting for the smallest fossil or chemical whisper of something that once swam. Mars is a time capsule, and we're trying to read the diary of a planet that never finished writing its story. Here's something wonderfully irrelevant. Mars has 2 moons, Phobos and Deimos. They're not round, not glamorous, just lumpy space potatoes that got caught in Mars's gravity and stuck around. Phobos is doomed, by the way. It's slowly spiraling toward Mars and will eventually crash or break into pieces. Think of it as a slow-motion moon funeral. Deimos, on the other hand, is drifting away, like it's tired of this drama and would rather be anywhere else. Want a detail that'll mess with your sense of space? The gravity on Mars is only 38% of Earth's, so if you weigh 150 pounds here, you'd be barely 57 on Mars. Jumping would be easy, carrying heavy stuff, way more manageable. But you'd still need a spacesuit because remember, no air, no heat, and enough radiation to scramble your cells like an egg. Speaking of the atmosphere, it's thin but not silent. Mars has wind. And when it blows through narrow canyons or across the jagged slopes of Olympus Mons, it hums. Not in the way Earth does, but in eerie, low frequencies. NASA's InSight lander even captured Martian wind audio filtered through instruments designed for seismic readings. It's more of a vibration than a sound, but it's there. Mars breathes, just not like we do. Scientists still debate how volcanically active Mars is today. Olympus Mons seems quiet, but smaller volcanoes may still bubble underground. There's also a strange thermal anomaly near a region called Elysium Planitia. Could be geothermal activity, could be past lava flows, or just Mars being mysterious as usual. Let's not forget Valles Marineris, the Grand Canyon of Mars, only it's not a canyon. It's a system of gashes stretching 4,000 kilometers long and 7 kilometers deep. That's longer than the United States and deeper than anything on Earth. It's as if Mars was split apart by something too big to explain tectonics erosion or some long-forgotten internal collapse. The surface of Mars didn't just age, it fractured. Oh, and sunsets on Mars, they're blue. That's right. Not orange, not pink. The thin atmosphere scatters light in reverse compared to Earth. So as the Martian sun dips low, the horizon glows in ghostly shades of cobalt. It's haunting, beautiful, quiet. If ever a planet could whisper you to sleep, it would be Mars at twilight. Mars is our cosmic mirror, close enough to resemble us, scarred enough to warn us. It holds our dreams of exploration, our fears of extinction, and our persistent childlike hope that something might still be waiting there under the dust. And now you leave it behind, dust settling, wind rising, Olympus Mons, fading into the red mist behind you. Next stop, a planet so big it could swallow every other planet in the solar system and still have room for dessert. There it is, looming ahead like a wall of storms and secrets. Jupiter, the big boss of the solar system. You don't arrive at Jupiter. You encounter it. You enter its gravitational influence. It's not just a planet. It's a miniature solar system all by itself. And at its center, a question scientists have been asking for decades: what's in Jupiter's core? Here's the wild truth we still don't know. It should be simple, right? Rock in the middle, gas around it like a cosmic jawbreaker. But Jupiter laughs in the face of simplicity. Beneath its thick, swirling clouds of hydrogen and helium, the pressure builds into something alien. The gases compress into liquid metallic hydrogen, a fluid so strange it behaves like both metal and liquid, conducting electricity, like a wire but sloshing like water. And somewhere beneath that, maybe a solid core, maybe a slush, maybe a weird gradient zone of semi-molten mush. Scientists still debate it, and it drives them bananas. One theory says the core eroded over time, dissolving into the surrounding metallic hydrogen, like a sugar cube in hot coffee. Others argue Jupiter never had a solid core at all. It may have formed through a wild gravitational collapse. It's like opening a Russian nesting doll and finding jelly inside. Meanwhile, above all that mystery is the eye-catching part, the clouds. Jupiter's surface, well, the top of its atmosphere, is a masterpiece of chaos. Bands of swirling storms constantly churning in east-west flows, stacked like ribbons of caramel and whipped cream. And within that maelstrom is the Great Red Spot, a hurricane larger than Earth that's been raging for at least 350 years, maybe more. No one was around to name it before telescopes. It's shrinking, oddly enough. The spot used to be over twice its current size. Scientists still debate whether it's dying or evolving into something new. Maybe in 100 years, it'll vanish altogether. Or maybe it'll rebound and start spitting out thunderbolts. Who knows? Jupiter doesn't take suggestions. And here's your off-topic but delightful fact of the night: Jupiter radiates more heat than it receives from the sun. It's basically a failed star still glowing from the energy of its formation. It could have been a twin to our sun if it had just picked up a little more mass. Instead, it became the solar system's giant bouncer, gravitationally bossing around comets, moons, and even other planets. Speaking of moons, Jupiter has 92 confirmed moons and counting. That's not a moon system, that's a family reunion. And one of them, Ganymede, is the largest moon in the entire solar system, bigger than Mercury, with its own magnetic field. Another moon, Europa, is covered in cracked ice with a possible subsurface ocean. More on that later. For now, just know Jupiter is never alone. Its magnetic field is monstrous, stronger than anything else in the solar system except the sun. It's so vast, if you could see it glowing like an aura, it would appear larger than the full moon in Earth's sky, even from 640 million kilometers away. And the radiation trapped within it is deadly. You'd need a spacecraft with the shielding of a tank just to survive a few hours near it. Jupiter is noisy too. Not in human terms, but if you had a radio tuned to the right frequency, you'd hear it hissing, cracking, and howling. Its magnetic field and interactions with solar wind produce bursts of radio waves, auroral storms that scream like static on cosmic steroids. Imagine trying to fall asleep next to a billion-volt Tesla coil. Oddly enough, despite its size and chaos, Jupiter has no solid surface. You can't land on it. You'd just fall. Through clouds, then denser clouds, then liquid layers, and eventually be crushed into non-existence by pressure. That's how Jupiter eats things gently, invisibly, eternally. And it does eat things. Jupiter's gravity acts like a massive vacuum cleaner hoovering up stray comets and asteroids that might otherwise hit Earth. It's been called the solar system's protector, but it's also been accused of occasionally redirecting those threats straight at us. So maybe frenemy is a better term. Here's something eerie. If you could somehow float at the top of Jupiter's clouds, it would look like an endless painting. No horizon, no landmarks. Just infinite swirling storms in every direction, like standing inside a mood ring having a nervous breakdown. There's no up or down, no firm ground, just movement and color and pressure and sound. Jupiter isn't a place, it's an experience. And speaking of pressure, imagine this hydrogen, the lightest element in the universe, being crushed so intensely it becomes a metal. Jupiter's inner mantle is made of this metallic hydrogen spinning and swirling and generating that colossal magnetic field. It's like the planet is powered by a giant dynamo, one so big it could fit 1,000 Earths inside it and still have room for snacks. Scientists still debate how old the Great Red Spot actually is. Some think it's the same one spotted in the 1600s. Others believe older storms died and were replaced. Either way, it holds steady spinning counterclockwise with winds reaching 430–680 km/h. It's basically the most persistent weather pattern in the solar system, like a tornado with tenure. So you float past Jupiter now, still feeling its gravity tug at your dreams, the storms roiling silently below. The deeper you look, the stranger it gets. No solid core, maybe. No answers, definitely. Just clouds, power, and the feeling that something ancient is watching you back. Onward now, past the thunder god of gas giants, toward a world so light it could float in water if only you had a tub big enough. And now, Saturn, the showstopper, the fashion icon of the solar system. You barely have to look, and your brain says, "Yep, that one's got the rings." Saturn is elegance in planetary form, massive golden and wrapped in bands of icy brilliance that make it look more like a divine ornament than a ball of gas and gravity. But beyond its beauty, Saturn is weird. Float in a bathtub weird. Here's the science: Saturn is the least dense planet in the solar system. Its average density is lower than water. In theory, if you could find a cosmic swimming pool wide enough, say a few 100,000 kilometers across, you could drop Saturn in and it would bob gently on the surface like a giant rubber duck. A terrifying, stormy, gas-filled duck, but still. That's not to say Saturn is small. It's huge, 95 times the mass of Earth. You could fit over 750 Earths inside it, but it's mostly hydrogen and helium fluffed out like a balloon. Its gravity barely holds its own outer layers in check. The planet bulges at the equator from spinning so fast. A day on Saturn lasts only about 10.7 hours. Blink and it's sunset. But let's talk about those rings, because really they deserve their own bedtime story. Saturn's rings aren't solid. They're made of billions of icy particles ranging from tiny grains to chunks the size of houses. They orbit the planet in thin, structured bands separated by mysterious gaps and shepherded by tiny moons. Some rings have braids, some shimmer with complex patterns. They're less than a kilometer thick in places, yet stretch out over 280,000 kilometers wide, so vast and delicate you could never see them up close and not feel a little small. And guess what? They're temporary. Saturn's rings are dying. Slowly, invisibly. The ice particles are falling into the planet like a slow-motion snowfall. Scientists estimate they may vanish completely in as little as 100 million years, blink cosmically speaking, and the most iconic thing about Saturn will be gone. Scientists still debate exactly how old the rings are. Some say they formed with the planet, others think they're much younger. Maybe the shattered remains of a captured moon. Either way, we're lucky to live in an era where they're still glowing. Speaking of moons, Saturn has over 140 confirmed ones. That's right. It's got more natural satellites than Jupiter. And one of them is arguably the most interesting place in the entire solar system, Titan. But we'll get to Titan next. For now, just imagine standing near Saturn. If you could float high above the clouds and survive the crushing pressure, you'd see golden bands swirling with pastel hues, pale yellow, beige, subtle browns. It's a calmer-looking planet than Jupiter, but don't be fooled. Saturn has storms. Massive planet-wrapping storms. Every 30 Earth years or so, it experiences a great white spot, a global megastorm so large it wraps around the entire planet. Like Jupiter's great red spot, but sneakier. And the winds, Saturn's atmosphere moves fast. Jet streams whip around its surface at speeds up to 1,800 kilometers per hour. That's faster than any hurricane on Earth, faster than sound in our atmosphere. You wouldn't hear the wind. You'd just feel your atoms being politely unarranged. And here's your strange, unnecessary detail for the night. Saturn has a hexagon on its north pole. No, seriously. A persistent, geometric, six-sided jet stream. It was first spotted in the 1980s, and it hasn't changed shape since. Scientists still debate how it forms, likely some kind of fluid dynamics magic involving vortex stability. But come on. A hexagon on a planet. It's like Saturn is trying to break math. Saturn also has auroras, glowing light shows produced by solar particles slamming into its magnetic field. But unlike Earth's dancing greens and purples, Saturn's auroras are eerie, ghost-like ovals, massive glowing rings that pulse silently over the poles. If the northern lights on Earth are a symphony, Saturn's auroras are a cathedral hum. And let's not forget the Cassini mission. That brave little spacecraft orbited Saturn for 13 years, delivering some of the most beautiful and haunting images ever taken of another world. It dove between the rings. It watched moons up close. It took a photo of Earth from behind Saturn, a tiny pale dot framed by celestial grandeur. Then, in 2017, it made one final plunge into the atmosphere, sacrificing itself so it wouldn't contaminate any of the moons with Earth microbes. Cassini burned up in Saturn's sky, ending one of the most poetic chapters in space exploration. Saturn is more than rings. It's history, its fragility, its quiet power. It doesn't shout like Jupiter. It doesn't melt your bones like Venus. It just spins gracefully, slowly losing its crown of ice and glitter like an ancient king in the last act of a slow-motion play. And as you drift past it, rings stretching out like vinyl grooves, clouds swirling in hushed harmony, you feel something odd. Not fear, not awe. Melancholy. Because Saturn is beautiful in a way that reminds you nothing lasts forever. Not even the most iconic things. Not even rings wide enough to hold 20 Earths side by side. So take one last look as the rings fade behind you and set your course toward Titan, a frozen moon, with lakes of methane and the sound of rain falling on alien shores. You coast now toward Titan, Saturn's largest moon, wrapped in a thick orange fog that makes it look like a dusty marble from afar. But don't be fooled. Titan isn't just some frozen chunk orbiting a gas giant. It's a whole world with weather landscapes and lakes. Except the lakes aren't water. They're made of liquid methane. That's right. Titan has a full-blown methane cycle just like Earth's water cycle. It has clouds, rain, rivers, shorelines, and seas, all made of hydrocarbons. Picture it. Methane rain falling from an orange sky, splashing into dark lakes that stretch for miles, lapping gently at icy shores under a thick, hazy atmosphere. It sounds like science fiction, but it's just Titan being Titan. And here's the twist: despite being nearly 1 billion miles from the sun, Titan is one of the most Earth-like places in the solar system. The resemblance is eerie. Wind-carved dunes, river deltas, cloud formations, mountains poking up through the mist. If you could ignore the bone-shattering cold and poisonous air, you might think you'd landed on some weird Arctic island. The temperature hovers around 179 degrees. That's colder than your freezer by, about 150 degrees. It's so cold that water ice acts like rock, literally. The mountains and cliffs made of solid H2O, rocks, water, groundwater. It's the one place where you could pick up a stone and later melt it into a cup of tea, assuming you like your tea deadly and methane-flavored. Still, Titan is unique. It's the only moon in the entire solar system with a thick atmosphere denser than Earth's even. Mostly nitrogen, but laced with methane and complex organic compounds. It's like standing inside an orange smog that never clears. You wouldn't be able to see the surface without radar, which is exactly how the Cassini spacecraft mapped it, by bouncing microwaves through the fog to sketch the shorelines of alien lakes. And those lakes? Massive. Kraken Mare is Titan's largest sea, bigger than Lake Superior. Dark, frigid, and full of methane and ethane. It even has waves. Slow, thick, syrupy waves that rise and fall in eerie silence. Some scientists think it might be possible to one day sail a robotic boat across those alien waters. Imagine the soft gurgle of liquid methane slapping against a titanium hull while Saturn looms huge in the twilight sky. Here's your out-of-nowhere fact. Scientists once detected what might be methane rain dripping onto Titan's surface, possibly even creating seasonal wetlands. So yes, somewhere out there, rain could be falling softly on a frozen lake beneath a sky full of stars. And it's not even Earth. Titan may even harbor life. Not Earth-style life, of course, but something. The building blocks are their complex carbon chemistry, liquid solvents, energy sources. It wouldn't be based on water, but on methane or ethane. Totally alien metabolism. Scientists still debate whether that's even possible, but Titan keeps their curiosity alive. In fact, NASA is sending a drone called Dragonfly there in the 2030s, because sometimes when a moon looks too interesting, you just have to fly a helicopter over it. And here's something to chew on before bed. If you had a decent wingsuit and the right gear, you could fly on Titan. Its gravity is low, and the atmosphere is thick, so with a running jump, you might just take off. You'd glide slowly through orange haze, floating over dunes and valleys, casting a soft shadow on terrain no human has ever touched. Titan isn't just weird, it's poetic, quiet, dreamlike. You can't help but wonder what it would feel like to walk there. No noise, just the gentle crunch of frozen sand underfoot, the pressure of thick air against your suit, and the dim golden light filtering down like an endless sunset. If Mars is a journal of the past, Titan feels like a riddle written in fog, something waiting to be understood. Scientists still debate the depth of its seas. Some think Kraken Mare could be hundreds of meters deep. Others argue it might even connect to a global subsurface ocean of water beneath the icy crust, just like Europa. That's right, two oceans. One of methane on the surface, one of liquid water deep below. Titan is layered in mystery. And if all that's not enough, Titan may also have ice volcanoes, cryovolcanoes. Instead of lava, they erupt slush. Ammonia, water, methane, all gurgling up from underground reservoirs and freezing instantly in the cold air. Imagine watching a volcano erupt, and instead of fire, it sneezes a glacier. Let's throw in one more lovely oddity. When sunlight hits Titan, it creates a glow called air glow, lighting the edge of its atmosphere in a gentle arc. Not bright, not dramatic, just a soft halo like a planet trying to remember the sun. And then just as softly, Titan fades behind you. The orange mist thins. The surface vanishes into cloud. The lakes grow still. You've passed the last Earth-like world for a while. What comes next? A planet that rolls through space like it's been knocked on its side, spinning lazily, like it just gave up halfway through its orbit. Uranus is waiting. Now you coast into strange territory, the outer planets, where the sun is just a pale coin and time seems slower somehow. And ahead, spinning like a toppled barrel rolling through the void, is Uranus. Yes, it's tilted, extremely tilted. Uranus doesn't just lean, it lies almost entirely on its side. Its axial tilt is about 98 degrees, which means it practically rolls around the sun, and nobody knows for sure why. Scientists still debate whether a massive collision knocked Uranus sideways early in its history, or if it just decided to be that way. But either way, Uranus is the eccentric uncle of the solar system. Quiet, distant, and definitely doing its own thing. What does that tilt mean? Well, for starters, its seasons are wild. Each pole gets 42 years of sunlight, followed by 42 years of darkness. That's right. Half a Uranian year, which lasts 84 Earth years, is spent in near total sunlight, and the other half in icy twilight. Imagine winter lasting from kindergarten to retirement. The weather reports would be chaos. Now Uranus doesn't exactly look like a thrill ride. From afar, it's a smooth, pale blue-green orb, soft and featureless. No swirling storms, no dramatic bands, but that's just because its cloud tops are unusually bland. Beneath that icy exterior, giant storms swirl unseen. In fact, when we look in infrared, we find bizarre, massive weather systems lurking beneath the quiet surface, some stretching thousands of kilometers wide. And about that color, it comes from methane. Uranus's atmosphere is made mostly of hydrogen and helium, but the methane absorbs red light, giving it that peaceful aqua hue. You'd think it's soothing. Don't be fooled. This is a world of extremes. Temperatures in Uranus's upper atmosphere dip as low as 224 degrees Celsius. That's colder than any other planet, even Neptune, which is farther from the Sun. Scientists still debate why Uranus is so cold. It doesn't seem to release internal heat like the other gas giants do. It's just frigid, like a planet that gave up being warm. But it does have heat hiding in strange places. Deep inside, Uranus might have an icy mantle wrapped around a rocky core, with pressures so high that the water inside behaves like a weird, slushy soup. Some models suggest the existence of a layer of superionic water, a bizarre state where water behaves like a crystal and an electrical conductor at the same time. That's right. Electrified ice slush. Space is deliciously weird. Oh, and here's your unexpected bedtime detail. Scientists suspect it rains diamonds on Uranus. No, not like the ones on necklaces. tiny diamonds crushed into existence under extreme pressure deep within the planet. Methane molecules break apart, carbon atoms compress, and bam, diamond rain. An invisible, glittering storm falling toward the core. Let that one shimmer behind your eyelids tonight. And moons. Uranus has 27 known moons, most of them named after characters from Shakespeare and Alexander Pope. There's Titania and Oberon, Miranda and Ariel, Umbriel and Puck, each of them icy, misshapen, mysterious. Miranda in particular looks like it's been shattered and stitched back together with giant cliffs and jumbled terrain that defies logic. One cliff, Verona Rupes, may be the tallest known in the solar system, 20 kilometers high. You could base jump for 10 minutes. Bring snacks. And the rings, yes, Uranus has rings. Not showy like Saturn's, but thin, dark, and gritty. They weren't discovered until the 1970s because they barely reflect light. Like most things about Uranus, they're subtle, moody, and a little underappreciated. Want a weird visual because of its sideways tilt? Uranus's rings and moons don't orbit around its equator like on other planets. They orbit around the vertical poles. It's like the planet is spinning on its belly, and all its accessories are awkwardly flailing around above and below, like it's trying to do a headstand with a hula hoop. And yet, despite all this, we've barely visited Uranus. Only one spacecraft, Voyager 2, swung by in 1986. It got a quick look, sent back some haunting images, and continued on to Neptune. Since then, nothing. Uranus has been sitting out here cold and quiet, waiting for someone to come back and ask, "Hey, why are you like this?" Scientists want to return. There's talk of an orbiter, a lander, maybe even atmospheric probes to explore its chemistry. Because Uranus isn't just weird, it's important. It holds clues to how gas giants form, how atmospheres behave, and what happens when a planet gets knocked sideways and just rolls with it. And here's a final strange fact: Uranus emits almost no excess heat. It doesn't glow from within like Jupiter or Saturn. It's just radiating exactly what it gets from the sun. Maybe it had a traumatic past. Maybe it cooled too fast. Or maybe it's just keeping its secrets. You drift past now, watching the pale blue disk shrink behind you, its rings barely a whisper. The moons twinkle faintly, caught in strange, tilted orbits. And ahead, a planet wrapped in mystery, whipped by supersonic winds, and boasting the darkest, deepest blues in the solar system. Neptune is calling. Now you drift toward the farthest known planet, where sunlight is barely more than a memory. Neptune, dark, distant, and furiously alive. From a distance, Neptune looks peaceful, a serene blue orb floating quietly in space. But that color, it hides chaos. Neptune has the most violent weather in the entire solar system. The winds here howl at over 2,100 kilometers per hour, faster than the speed of sound on Earth. They'd rip your atoms apart before you even finished saying, "Hey, this isn't so bad." And just like with Uranus, scientists still debate how Neptune manages such incredible wind speeds. The planet receives very little solar energy, less than 1/900th of what Earth gets. Yet it fuels storms so intense they make Jupiter's look like drizzle. So where's the power coming from? Some theories point to internal heat. It radiates more than twice the energy it receives. But why still a mystery? Neptune won't tell us. Let's talk about that color. Neptune's deep azure isn't just methane doing its usual absorb the reds, reflect the blues trick. Uranus has methane too, but Neptune is bluer. So clearly something else is going on, possibly some unknown compound or subtle difference in the upper atmosphere. Another item in the long list of Neptune's yes but also no responses to science. One of Neptune's defining features is the Great Dark Spot, a massive storm system first spotted by Voyager 2 in 1989. It looked like a black eye against Neptune's vivid blue skin. But when the Hubble Space Telescope looked again in the 1990s, it was gone. Then, it came back, in a different place. As if the planet was saying, I don't do reruns, I do sequels. These giant storms appear and vanish mysteriously, forming in the upper atmosphere and drifting across the planet for years before dissolving. Scientists still debate what causes them to form or what makes them disappear. Neptune is like that, flashy, dramatic, and totally unpredictable. And beneath all that atmosphere, layers of strange. The upper atmosphere is methane-rich and frigid. Deeper down, pressure builds. Hydrogen and helium compress. The gases turn into supercritical fluids, no longer behaving like normal liquids or gases. Deeper still, there's a slushy mantle of water, ammonia, and methane, possibly electrically conductive. Yes, once again, diamond rain. Like Uranus, Neptune's pressure is so intense that carbon atoms could be crushed into tiny diamonds, drifting slowly down through the mantle. Not sparkly Hollywood diamonds, just pure carbon formed under unimaginable pressure. Every planet out here has a flair for the dramatic. Neptune might even have a solid core, rocky, metallic, perhaps twice the size of Earth. But like Jupiter and Saturn, we've never seen it, never touched it. All we have are gravitational wobbles and models. And speaking of things we have seen, say hello to Triton, Neptune's largest moon. Triton is weird. First of all, it orbits backward. That's right, retrograde motion. Every other large moon in the solar system goes in the same direction as its planet's rotation. But not Triton. It's doing donuts in reverse. Scientists think Neptune might have captured it from the Kuiper belt, yanking it into orbit and disrupting whatever moon system it had before. Triton's surface is covered in nitrogen ice. It's cracked and scarred with weird cantaloupe terrain and cryovolcanoes that spew icy plumes instead of lava. Voyager 2 spotted geysers erupting from its surface, dark material shooting 8 kilometers into space before settling back down. That's right, Triton is alive, at least geologically. And it won't last forever. Because it orbits backward, Triton is slowly spiraling inward. One day, millions of years from now, it will either crash into Neptune or be torn apart, possibly forming new rings. Cosmic recycling, Neptune style. Neptune also has 6 faint rings, thin, dusty, incomplete loops. Not nearly as elegant as Saturn's. More like smoky halos. If Saturn is the prom queen, Neptune's rings are the artist who shows up late and leaves early. Understated, a little mysterious, but definitely cool. Here's a completely unnecessary fact. Neptune takes 164.8 Earth years to orbit the Sun. That means it just completed its first full orbit since being discovered in 1846. So in Neptune years, it's basically a toddler. A chaotic, icy toddler throwing temper tantrums at 2,000 kilometers per hour. And yet we barely know it. Voyager 2 is the only spacecraft ever to visit, and it only spent a few hours flying past. Everything else we've learned, rings, storms, moons, it's all thanks to telescopes from far, far away. Neptune remains the most unexplored planet, but it's also one of the most alluring. There's something about that dark blue, that mystery, that sheer, violent elegance that pulls you in. If you ever stood floated above its atmosphere, you'd see shadows of storms swirling beneath you. You'd feel the magnetic field twitch around you, off-kilter, tilted strangely from the planet's axis. You'd hear nothing because space doesn't carry sound, but you'd sense the motion. Neptune doesn't shout. It hums in oceanic silence. Scientists still debate what drives Neptune's internal heat engine. They still guess at the nature of its deep mantle. And they wonder, could Triton, with its icy volcanoes and secret seas, be hiding life? Probably not. But then again, probably not, is also what we said about finding lakes on Titan or diamonds falling through Neptune's clouds. Space likes to surprise us. Now, as Neptune drifts behind you wrapped in silence and wind, the sun looks like a star again. You're almost at the edge, but not quite. There's still one more place to visit. Small, cold, once a planet, still a mystery. Pluto awaits, and now the light grows faint. The solar system becomes a whisper. You're beyond the orbit of Neptune, out where the sun is little more than a glint, no brighter than a full moon. This is where Pluto lives. A world so small, so far, it was demoted from planethood, yet still manages to capture the imagination, like royalty in exile. Let's get the headline out of the way. Pluto has a heart. Literally. A massive, pale, heart-shaped glacier called Tombaugh Regio spreads across its surface. It's made mostly of nitrogen ice, and one lobe of the heart, Sputnik Planitia, is especially strange. It pulses, not like a heartbeat, but through seasonal changes and thermal convection it moves. Gently, slowly, like it's breathing. And that's not just poetic. Pluto's surface isn't dead. Sputnik Planitia shows signs of active geology convection cells, the size of cities where nitrogen ice cycles upward and downward in a slow planetary churn. This means Pluto's insides aren't entirely frozen. There's warmth, motion, memory. How is that possible? Scientists still debate. Maybe radioactive elements in Pluto's core provide enough internal heat. Maybe there's a subsurface liquid water ocean kept from freezing solid by antifreeze chemicals like ammonia. That's right, Pluto might have a warm ocean under its icy skin. In the Kuiper Belt, with that little sunlight, against all odds, and yes, it's still geologically young, you'd expect a body this small, only about 2/3 the width of our moon, to be long dead. Cold rock, dusty snowball. But then the New Horizons spacecraft showed up in 2015 and said, guys, it's alive. Cracked plains, jagged mountains made of water ice and hazy atmospheric layers that caught the last rays of a distant sun. It wasn't just beautiful, it was surprising. Let's pause for a second and talk about that mission. New Horizons traveled nearly 5 billion kilometers, took over 9 years to get there, and had only one shot, one pass, moving at 14 kilometers per second. And it nailed it. For a few hours, humanity saw Pluto up close, the ridges, the canyons, the heart, the haze. Then it kept going, slipping away into deep space. And Pluto slipped away too, leaving behind only photos, data, and wonder. But back to that heart. It does more than look poetic. Sputnik Planitia is perfectly placed to affect Pluto's entire orientation. Its mass distribution actually pulled the planet into a stable tilt over millions of years. In other words, Pluto's heart controls how it spins. How's that for metaphor now about that demotion? In 2006, the International Astronomical Union reclassified Pluto as a dwarf planet. People got mad. T-shirts were printed. Children cried. But the science holds up. Pluto shares its neighborhood with lots of similar icy bodies in the Kuiper Belt, and it hasn't cleared its orbit. So technically, it doesn't meet the updated definition of a planet. But emotionally, come on. It's Pluto. Of course it's a planet. It has mountains taller than the Rockies. It has glaciers and atmosphere seasons. It has moons. Let's talk about those moons. Pluto has 5 known moons. The largest is Charon, and it's massive enough that the Pluto-Charon system actually orbits a shared center of mass located outside of Pluto's surface. That's right. Pluto and Charon are technically a binary dwarf planet system spinning around each other like dancers in a slow, frozen waltz. Charon is strange too. Its surface is scarred with canyons, craters, and a massive dark blotch across the North Pole, nicknamed Mordor. Because of course it is. And like Pluto, Charon might also have an underground ocean long frozen, or maybe still sloshing faintly under layers of ice and ammonia. The other moons, Styx, Nix, Kerberos, and Hydra, are small, irregularly shaped and spinning chaotically. If you stood on one, the sky would change unpredictably. No steady moonrise, just dizzying twilight and shifting shadows. Pluto's moons don't just orbit, they tumble. Here's a fun fact to sleep on. Pluto has blue skies. Yeah, the atmosphere, thin as it is, scatters sunlight just enough to create a gentle blue haze during sunrise and sunset. Not unlike Earth. But instead of oxygen and nitrogen, it's mostly nitrogen with traces of methane. Too faint to breathe, too beautiful to forget. And the sun sets, cold, quiet. The sun casts long shadows across the frozen plains. The light fades into cobalt and violet, and the stars come out fast. There's no waiting for night on Pluto, it just falls. Scientists still debate what keeps Pluto's surface active. Is it residual heat from formation a hidden radioactive core? Or just the stubborn persistence of a planet that refuses to die quietly? Whatever the cause, it's enough to make Pluto more than a frozen rock. And that heart. Always that heart. It's cracked. It's ancient. But it moves. Like something trying to tell you, I'm still here. Now as Pluto fades behind you, smaller, dimmer, quieter, you drift beyond the planets, beyond the IAU definitions. Out where the sun's grip loosens and the solar system gives way to the vast, icy shell of something stranger. The Kuiper Belt awaits. Past Pluto now, past everything the textbooks once called planets. You've crossed into a realm that doesn't feel like part of the solar system at all. It's colder, darker, lonelier. Welcome to the Kuiper Belt, a vast frozen graveyard of ancient debris, icy worlds, and forgotten leftovers from the solar system's chaotic birth. Imagine a ring of icy rubble stretching from 30 to over 50 astronomical units from the sun. That's over 7 billion kilometers out, and that's just the inner edge. Out here, the sun is barely more than a bright star. It casts light, yes, but not warmth. The Kuiper Belt is where sunlight arrives tired. It's like the solar system fell asleep and left this dusty attic behind. And what's in the attic? A lot more than you might expect. We used to think Pluto was a loner. Then we realized it was just the most famous member of a huge population of icy bodies called Kuiper Belt objects, or KBOs. These include weird potato-shaped things like Haumea, which spins so fast it's squashed like a rugby ball make-make, which has a hint of an atmosphere, and Eris, which is more massive than Pluto, and helped trigger the whole Pluto isn't a planet crisis. Yeah, that Eris. But for all we've learned, the Kuiper Belt remains wildly mysterious. These objects are distant, dim, and often barely detectable. We catch glimpses as they drift across the background, stars, tiny dots of motion in a vast, still sky. Scientists still debate exactly how the Kuiper Belt formed. Was it a dense disk of material that never quite coalesced into planets? Or was it once packed tighter, then flung outward by Jupiter and Neptune in a chaotic gravitational tug-of-war? Either way, what we're left with is cosmic driftwood. Primitive, preserved, unchanged for over 4.5 billion years. Here's your irrelevant but excellent fact. Some Kuiper Belt objects have moons, tiny ones. One KBO called 486958 Arakoth, formerly known as Ultima Thule, looks like two icy lobes gently pressed together. New Horizons flew past it in 2019, revealing a contact binary, two bodies that kissed instead of colliding. It's adorable, and also extremely helpful for understanding how planets might have formed through slow, sticky accumulation instead of fiery impacts. Speaking of which, let's talk about what it's like out here. You're in a realm of silence. There's no ambient noise, no sunlight strong enough to cast sharp shadows. The stars look slightly different, more clustered toward the galactic plane. Everything feels ancient, slow, and fragile. Space is no longer an adventure. It's a preservation chamber. You could drift for centuries here and pass countless objects most too small to name. The Kuiper Belt likely contains hundreds of thousands of KBOs larger than 100 kilometers across, and perhaps billions of smaller ones. It's a crowded emptiness, a cosmic storage locker full of ice and memory. And yet, it's not chaotic. Not like the asteroid belt where collisions happen more often. The Kuiper Belt is so vast that the distance between objects can be tens of millions of kilometers. You could spend a lifetime flying through it and never hit a thing. It's a paradox full of stuff, but too spread out to feel it. Now let's talk philosophy for a moment. The Kuiper Belt is not a place for life, at least not as we know it. But it's a place about life. Every icy rock here is a time capsule, a leftover from the solar system's baby photos. Preserved chemistry, frozen organics, the ingredients for life waiting patiently in the deep freeze, waiting for a planet or a collision or a cometary tail to give them a stage. Scientists still debate whether objects from the Kuiper Belt brought water and perhaps even the building blocks of life to Earth. Many comets come from here, and when they crash into planets, they deliver more than just drama. They deliver ingredients. Let's not forget that everything we are, our water, our carbon, our molecules, probably started as cosmic leftovers. You are, in some poetic sense, made of Kuiper Belt goo. Here's your fun mental image. You're standing on a KBO. It's only a few kilometers wide. The gravity is so weak you could jump into orbit with a good pair of boots. The sun is a pale dot. The stars are sharp. The silence is absolute. Every sound you hear is your own breath inside your helmet. And ahead, just ice, dust, and a darkness so deep it doesn't feel black, it feels like absence. And yet you're still not at the edge. Because beyond the Kuiper Belt, even farther out, lies the scattered disk home to icy bodies on extreme stretched-out orbits. Some, like the infamous Sedna, drift in elliptical paths that take them thousands of years to complete one lap around the sun. And even beyond that, the Oort cloud, the theoretical shell of icy debris that might mark the true edge of the sun's influence. We've never seen it directly. It's too far. But we think it's there, a spherical swarm of comets cradling the solar system in a shell of ancient ice reaching almost halfway to the next star. But we'll get there soon. For now, let the cold wrap around you like a blanket. The Kuiper Belt is quiet, still. And it doesn't care about planets or classifications or what year it was when Pluto lost its crown. It just orbits. Slowly. Forever. The light fades even more now. You're so far from the sun, it no longer feels like you're in the solar system. It feels like you're leaving it behind. One more push, and you're in the scattered disk, the cosmic halfway house between the structured orbits of planets and the drifting ghosts of interstellar space. This region is wild. Objects here don't follow neat circular paths. Their orbits are stretched into dramatic ellipses like comets forever caught in a cosmic slingshot. And the most famous resident of this strange frontier, Sedna. Sedna doesn't behave. It orbits the sun at an astonishing distance between 76 and 937 astronomical units. That means at its farthest, Sedna is over 30 times farther from the sun than Neptune. One Sedna year takes 11,400 Earth years. It was probably last closest to the Sun when mammoths were alive. And here's where things get really unsettling. Sedna shouldn't even be where it is. Its orbit is too far out, too strange, too untethered. It doesn't fit with the gravitational influence of the known planets. Scientists still debate what yanked Sedna into this orbit. Was it a passing star billions of years ago, the gravitational echo of a rogue planet? Or could it be something we haven't seen yet? That's right. Sedna is one of the key pieces of evidence for a theoretical world that some call Planet 9. Here's the pitch. A handful of extreme trans-Neptunian objects like Sedna all have orbits that seem clustered, tilted in the same direction, elongated in similar ways. It's like something massive out there is tugging on them gently, hurting them with invisible hands. That something might be a planet up to 10 times the mass of Earth, orbiting hundreds of AU from the Sun. Maybe it's hiding in the galactic glare. Maybe we've just never looked in the right place. But the math is tempting. Scientists still debate its existence. Some are convinced. Others think the clustering might be coincidence or the result of observational bias. But the mystery remains something sculpted Sedna's orbit, and Sedna is just the beginning. The scattered disk is full of similarly odd worlds. Objects with names like Gongong and Leleakuhonua following bizarre tilted orbits that take them on epic journeys through the solar outskirts. Some might loop back every few thousand years. Others, like 2012 VP-113 nicknamed Biden for reasons lost to cosmic history, linger in the twilight zone where the sun barely whispers. And yet these frozen wanderers may hold clues to the early violence of our solar system. Think of it in the first few 100 million years. Planets migrated, flung debris outward, collided, merged. The scattered disk is like a scrapbook of that time only. Instead of photographs, we have ice balls tumbling through space. Here's your unnecessary but charming fact. Some of these distant objects are reddish. Not from rust, but from tholins, organic compounds formed by solar radiation bombarding methane ice. These tholins coat the surfaces of KBOs and scattered disk objects, giving them subtle hues, red, pink, even plum. Space isn't just black and white, it blushes. Let's talk time for a moment. If you were standing on Sedna, the sun would be just another star. Slightly brighter, sure, but nothing like the warm disk you know on Earth. Days and nights would be irrelevant. Seasons meaningless. Sedna rotates slowly, completing a spin every 10 hours or so. But without much sunlight, there's no morning or evening. Just cold. And what a cold it is. Temperatures here drop below 240 degrees Celsius. Even nitrogen gas, so light and mobile on Earth, is frozen solid. The entire surface is locked in ice. If you coughed, the vapor would crystallize before it left your lips. But despite the cold, these worlds are not lifeless in spirit. They're records. Places where the past is frozen in place, where chemistry has paused, but not disappeared. And here's the wild part. Sedna's elongated orbit means it hasn't even gotten close enough for detailed observation. New Horizons flew past Pluto. But Sedna, it's still a blurry pixel on the edge of detection. Yet it's real, and it might not be alone. Some scientists speculate that the scattered disk could contain thousands of minor planets, maybe even objects bigger than Mars lurking unseen in the black. We've only just started mapping this region. Every year brings another strange object with another strange orbit. The solar system doesn't end cleanly. It dissolves into uncertainty. And then there's the existential angle. You are now in a place where the sun is no longer the boss. Its gravitational grip is weakening. Out here, things move to the rhythms of the galaxy. Other stars long ago may have passed nearby, and nudged some of these objects. And as we orbit the Milky Way, we pass through clouds of interstellar dust, magnetic ripples, gravitational anomalies. Occasionally, these influences knock an icy body inward, turning a frozen loner into a glowing, long-period comet. It falls toward the sun flares with light, then slingshots back into the dark for another few thousand years. You might see it once in a lifetime, or never again. These comets are messengers, pieces of the past hurled toward the inner system carrying ancient materials, perhaps even ancient molecules. Some may have struck Earth billions of years ago, seeding it with water or organics. Life, it turns out, might have been imported, delivered by frozen postal service from the scattered disk. You drift now, feeling the vastness close in. Stars crowd the sky. The sun is nearly gone, and ahead lies something even less certain. A place we've never seen. A theoretical realm where ice outnumbers light and comets sleep for eons. The Oort cloud is calling. And now, you're gone. Gone from the planetary system. Gone from the realm of moons and rings and orbiters. The sun is a pinprick behind you, barely brighter than Sirius in Earth's sky. You have crossed into the place where the solar system technically ends, and something even stranger begins. Welcome to the Oort cloud, the most distant, most mysterious, most speculative part of our cosmic neighborhood. No human has ever seen it. No spacecraft has ever reached it. But scientists are confident it's there. Why? Because of comets, long-period comets with orbits so vast and stretched that they can only come from some unseen, distant shell. These icy wanderers fall in from the dark, like messages in bottles, some with periods that stretch into the millions of years. The Oort cloud is believed to be a spherical swarm of frozen bodies surrounding the solar system in all directions, like a cosmic snow globe. It begins somewhere around 2,000 AU from the Sun, that's 2,000 times the Earth-Sun distance, and may extend out to 100,000 AU, almost halfway to the next star. Wrap your mind around that the Oort cloud might be a light year wide, but it's not a wall. It's not a shell of ice. It's a ghostly cloud of trillions of icy fragments, comets, debris, leftovers from the dawn of the solar system, all loosely orbiting the sun in lazy, fragile ellipses. Most will never fall inward. They just drift, silent, forgotten, waiting. What's in them? Ice for sure, water, ammonia, methane, dust, organics, and maybe the kind of carbon compounds that once rained down on early Earth and whispered the first sentences of life. The Oort cloud might be the freezer where the solar system's original ingredients have been kept perfectly preserved for billions of years. You could spend eternity out here and never bump into a thing. It's vast, empty in a paradoxically crowded way. It's like standing in a warehouse the size of Earth filled with only a few scattered marbles, each one precious, ancient, wrapped in 4.1 billion years of silence. Here's a detail to fall asleep thinking about. It's possible that stars passing near the solar system disturb the Oort cloud. Every few million years, one might swing close enough to nudge a few icy bodies inward. These become comets, arcing toward the sun, flaring with heat, and often breaking apart before returning to the cold. Some comets survive, some crash, and some may change everything. There's a theory still debated, of course, that some of Earth's mass extinctions may have been triggered by distant stellar flybys shaking the Oort cloud. A comet flung inward, slamming into Earth, changing climates, altering ecosystems. One chunk of ice from 1 trillion miles away, and poof, goodbye dinosaurs. The Oort cloud reminds us distance doesn't always mean safety, but it's not just dangerous, it's majestic. Think about it. A comet like Hale-Bopp spent most of its life in the outer Oort cloud. Then some gravitational nudge sent it on a 4,000-year journey inward. It glowed. It showed its tail. It was seen by people, animals, maybe even ancient civilizations the last time it passed. Then it disappeared again, headed home. Scientists still debate where the Oort cloud ends and interstellar space begins. Technically, the sun's gravity stretches forever, getting weaker and weaker. But at some point, the interstellar medium, the space between stars, becomes dominant. Solar wind stops. The heliosphere fades, and the sun's influence becomes a whisper. Out here, even time feels different. A single orbit might last tens of millions of years. A comet flung from the Oort cloud might take longer to return than any species survives. Some of them might never come back. Want an unnecessary but poetic fact. A spacecraft traveling at 60,000 km/h faster than anything we've built would still take thousands of years to reach the outer Oort cloud. If you launched a message there today, it would arrive long after your language has vanished. Your cities crumbled, your civilization rewritten by time. And yet it's part of your home, part of the solar system. Just the outer skin, the forgotten edge. Some think the Oort cloud may have captured icy bodies from other star systems during the sun's early years. Back when stars were born in clusters, they might have stolen debris from each other. So perhaps, just perhaps, some of the objects out here are not from our solar system at all. Interstellar immigrants caught by gravity and kept as souvenirs. You're floating now in this imagined sea of drifting glass beads. There's no light, no sound, just cold, deep, true cold, and the soft sense that this is where it all came from and where it may all return. You pass one object, a small icy sphere a few dozen kilometers wide. It's been orbiting the sun for billions of years, unseen, untouched. You give it no name. You don't need to. It doesn't know it's been found. Behind you, the sun is just a memory. Ahead, interstellar space, the realm between stars, the place Voyager 1 has already entered. The place we may never truly visit except through imagination and radio waves. You've reached the edge of home. And just beyond, the next star, the next story. You drift now in the great in-between. Behind you, the sun, dim and distant. Before you, the black sea between stars, interstellar space. You're outside the solar system now. No planets, no Kuiper belt, no Oort cloud. Just emptiness humming with the background static of the galaxy. But even emptiness isn't truly empty. Out here, space is filled with something called the interstellar medium, a whisper-thin soup of gas dust and magnetic fields. It's so sparse that you'd pass through entire light years and only hit a few atoms. But over time, it builds. It flows. It shapes the boundaries of entire star systems. This is the realm that Voyager 1 entered in 2012. A machine built in the 1970s, still calling home from more than 24 billion kilometers away. Its instruments are weak now, its power fading. But it's out there, alive, sending data, floating through the dark like a bottled message thrown into a cosmic tide. Here's a thought to hold: Voyager 1 is the farthest human-made object in history. It carries a golden record, literally a phonograph filled with music greetings in dozens of languages and the sounds of Earth. Rain, birds, heartbeats. It was made with the quiet hope that someday someone or something might find it, that it might say we were here. But space doesn't care about stories. Interstellar space is governed by gravity and silence. Temperatures plunge to just a few degrees above absolute zero. Radiation from stars leaks in from all directions. The magnetic field here isn't from the sun anymore. It's from the Milky Way itself. A slow tide of charged particles shaped by the galaxy's spiral arms. Scientists still debate exactly where the solar system ends. Is it the heliopause? The outer shockwave where the solar wind dies? Or the point where the sun's gravity finally gives up and hands you to the galaxy? Definitions blur out here. Borders dissolve. Want a number to dream about? It would take you over 75,000 years to reach the closest star system, Alpha Centauri, even traveling at the speed of Voyager 1. At that rate, we're not explorers. We're messages in bottles. Hopeful, slow, maybe eternal. Yet this space, this cold frontier, is not empty of meaning. It contains rogue planets, free-floating worlds unbound by any star. Billions of them. Kicked out during the violent births of planetary systems, they now wander through the dark like cosmic orphans. No sunrises, no seasons, just endless silent orbit around nothing. Some of them may have atmospheres, internal heat, subsurface oceans warmed by radioactive decay. It's not impossible to imagine life surviving here, clinging to warmth in the deep dark. A whole biosphere evolving on a world that's never known daylight. Let that sink in. Not all life needs a sun. Then there are the interstellar comets like 2I Borisov and Oumuamua. Visitors from other star systems. They fly in from deep space, loop around the sun once, and vanish again. No orbit. No return. Just a pass-through. And when we see them, we get maybe a few weeks, days sometimes to observe, to wonder, to guess where they came from. Oumuamua, for instance, arrived in 2017. It was small, fast, and strange. It didn't behave like a typical comet or asteroid. It accelerated slightly as it left the sun with no visible tail. Some scientists still debate whether it was a natural object or something else. A shard of alien tech, a cosmic sail, most agree it was natural. But no one knows. And that's the thing about interstellar space, no one knows. It's not mapped, not explored, not yet. We don't know what's between the stars, what ancient debris, what frozen worlds, what forgotten echoes are drifting out here waiting to be found. If the solar system is a house, then this is the yard. And it stretches for light years. But space doesn't rush. It waits. You drift past particles of iron from dead stars, dust grains formed before the sun existed, perhaps even complex molecules, precursors to life baked in the bellies of red giants and blown outward in stellar winds. These clouds, thin as breath, will someday collapse, again form stars, planets, maybe people. You're floating through the ingredients of future worlds. And through it all, there's still movement. The solar system is not standing still. It's orbiting the center of the Milky Way at over 828,000 km/h. It takes about 225 million years to make one full galactic loop. That means dinosaurs were just starting out the last time Earth was here in the galaxy. Even now, we're flying, spiraling. The planets dance around the sun, and the sun itself orbits the galaxy, towing everything behind it in a glowing ribbon of gravity. You're in that ribbon, moving forward, always forward. No boundaries, no roads, just direction, momentum, and a strange kind of calm. Because this deep space silence isn't empty. It's patient. The stars are far apart, but the galaxy is full. And even here, where the night never ends, something flickers. Data from a dying probe. A streak of dust. A dream of arrival, and you're just passing through. A thought drifting on the edge of light, a brief visitor in a vast place. Ahead lies the galactic disk, the spiral arms, the great river of stars. But for tonight, let's pause, float, and breathe. You continue drifting, weightless, silent, wrapped in the hush of interstellar space. But now you feel it, a subtle shift, the soft tug of something vast, not the pull of a planet or the heat of a star, but the unmistakable presence of structure. Gravity doesn't rest even in the dark. You are being pulled toward the Milky Way's spiral arms, toward the bustling, glowing cityscape of our galaxy. Let's pull back and see the big picture. The Milky Way is a barred spiral galaxy about 100,000 light-years across. That's a number so absurdly huge your brain can't touch it. A beam of light takes 100,000 years to get from one side to the other, and you live in one quiet little cul-de-sac called the Orion Arm, roughly 27,000 light-years from the galactic center. You might think of space as mostly empty, but the galaxy is alive. It's filled with stars, dust, gas, magnetism, radiation, dark matter, and mysteries we haven't even named yet. There are about 200 billion stars in the Milky Way. Maybe more. Maybe 1 trillion planets. And somehow one of them is home. But you're not home now. You're in the galactic outskirts, moving through the diffuse halo that surrounds the spiral arms. It's not a clean border. There's no welcome to the Milky Way sign. But the stars get denser. The light gets richer. And you feel for the first time in hours that familiar electric prickle life might be nearby. You pass through clouds of gas hydrogen, mostly waiting to become stars. These are the stellar nurseries regions where gravity will someday collapse the dust into suns. Some of them are already glowing, lit from within by new stars pushing outward with radiation and heat. These are the H2 regions, vast bubbles of light in an ocean of shadow. And some bubbles pop. Stars die. Supernovas erupt. Whole systems are shredded and remixed into something new. The elements in your body, carbon, nitrogen, iron, were forged in these dying stars. You are, as Carl Sagan famously said, star stuff. But even that doesn't capture the intimacy. You're not just made from stars. You are made from their endings. And here's something to sleep on: the atoms in your left hand may have come from a different supernova than the atoms in your right. Now, as you glide deeper, the galactic arms stretch ahead like glowing rivers. One band of starlight arcs across your vision, the galactic disk viewed from the inside. You've seen it from Earth before, just as a pale stripe across the night sky. But here it's a wall of light. Billions of stars packed so closely that darkness almost disappears. And what's holding it all together, that's where things get weird. Because gravity alone shouldn't be enough. Galaxies spin too fast. Stars orbit too quickly. By the math, the Milky Way should fly apart like a broken carnival ride. But it doesn't. Something invisible is holding it together. Something massive. Something we call dark matter. We don't know what dark matter is. We can't see it. We can't touch it. But we can watch its effect. It makes up about 85% of the matter in the universe. It shapes galaxies, bends, light slows expansion. It is the scaffolding of reality, and we are just squatting on it. Scientists still debate whether dark matter is made of particles or whether it's some tweak in the laws of gravity we haven't understood yet. Either way, you're swimming in it. Right now. Always. And surrounding the Milky Way. A dark matter halo. Spherical. Immense. Unseen. It's what allows the galaxy to hold itself together, to spin as one, to exist. And just like that, your focus shifts again from the spiral arms to the core. The center of the Milky Way is 27,000 light-years behind Earth, but it burns in infrared and radio waves pulsing like a hidden heart. There lies Sagittarius A, A supermassive black hole 4 million times the mass of the Sun. It's silent, it's invisible, and it's the axis around which the entire galaxy dances. It doesn't devour stars constantly. It's mostly calm. But when something gets too close, a star, a gas cloud, it can erupt in flares, sending X-rays out into the arms. It's like a sleeping god with occasional lightning strikes. Want a weird fact? The solar system orbits the Milky Way's center at about 828,000 kilometers per hour. Even at that speed, it takes us 225 to 250 million years to make one full galactic lap. That means the last time Earth was in this part of the galaxy, the dinosaurs were just getting comfy. You've completed only 1/3 of a galactic orbit in all of human history. And all around you now, the stars. You are no longer near any one system. You are between them, drifting in the quiet spaces where starlight overlaps. It's not empty, not like interstellar space in the solar system, but it's still vast. The distances between stars average a few light years. That's about 9 trillion kilometers each. And yet the galaxy feels dense. The sky here is textured, layered with red dwarfs, blue giants, white-hot younglings, and old orange embers. Every point of light might have planets. Every planet might have moons. Every moon might have secrets. Scientists still debate the number of habitable worlds in the galaxy. Some models say tens of millions. Others say hundreds of billions. And then there's the Fermi paradox, if the galaxy is so full of stars and planets and time. Where is everybody? Maybe they're here just quiet. Maybe they came and left. Maybe intelligence always collapses, or maybe we're early. And for now, you drift. Past suns, past comets with foreign chemistry, past exoplanets with weird atmospheres, and maybe even oceans. You are no longer just exploring planets. You are exploring potential. You're not in the solar system anymore. You're in the galactic neighborhood now. You're in the thick of it now. No longer clinging to the sun's gentle gravity, you float between stars, free, directionless, dazzled. This is the galactic neighborhood, and it hums with motion. Stars orbit the galactic center like runners on a cosmic track, but none of them move in straight lines. They wobble, they drift. They're tugged by unseen forces, by ancient collisions, by ripples in space-time left behind, by stars long gone. And you, tiny traveler, are caught in that dance. The stars around you aren't evenly spaced. There are clusters, associations, streams, some of them remnants of old galaxies that the Milky Way ate. That's right. Our galaxy is a cannibal. Over billions of years, the Milky Way has absorbed smaller galaxies, shredded them into ribbons, and folded their stars into its spiral arms. You can still see some of those stellar streams today, trails of stars stretched across space like spilled glitter. Right now, you might be drifting through the faint remnants of the Sagittarius dwarf galaxy, one of the Milky Way's past snacks. It once orbited peacefully, but got too close. Gravity tore it apart. Now it's part of us. And if the Milky Way is the hunter, it also has prey in sight. The large and small Magellanic Clouds. 2 irregular dwarf galaxies are being drawn in. Eventually, they too will be absorbed, their stars redistributed like puzzle pieces, their gas feeding new generations of suns. Here's the thing, galaxies are not passive. They collide, they devour, they shape each other, and a collision is coming. In about 4 billion years, the Milky Way and Andromeda, our closest galactic neighbor, will smash into each other. Not like bumper cars, but more like dancers in slow motion. Their stars are too far apart to collide directly, but the gravitational chaos will be spectacular. Tidal forces will tear spiral arms into tendrils. Supermassive black holes will spiral toward each other in a deadly embrace. Entire star systems will be flung out into intergalactic space. Scientists still debate how violent that merger will be. Some predict a serene mixing. Others suggest bursts of star formation and chaos. Either way, the final result will likely be a new galaxy, an elliptical monster, sometimes nicknamed Milkomeda. Poetic right, and your sun. Assuming it's still around, it'll likely drift to a new orbit, maybe closer to the center, maybe farther. But Earth by then will be long gone baked and swallowed by the dying sun. So this galactic drama will unfold without us. Unless our descendants find a way to hitch a ride on another star. Let's zoom in again. Between the spiral arms and quieter patches of dust and gas, you'll find stellar nurseries, places like the Orion Nebula, where stars are being born even now. Dense clouds collapse under gravity, heating up, spinning, forming protostars surrounded by disks of dust. From those disks, planets. From some of those planets, oceans. From some of those oceans, maybe something more. Life. The galaxy is old, and time has had so many chances. There are planets everywhere, over 5,600 confirmed exoplanets and counting. Some are hot Jupiters skimming the edges of their stars. Others are super-Earths, rocky giants with crushing atmospheres. Some orbit in the habitable zone where liquid water might exist. And then there are the rogue planets drifting alone, wrenched from their stars, cold but possibly warm within, cradling oceans under icy shells, hiding life in the shadows. And if we've barely scratched the surface of our own star's backyard, imagine what we've missed out here. Here's your weird interstellar bedtime snack. Scientists have identified free-floating gas clouds with the building blocks of amino acids. That means complex organic chemistry is not rare. It's everywhere. The Milky Way isn't just a star factory, it's a chemical mixing bowl. It's been running the experiment of life on repeat for billions of years. So, where is everyone? The Fermi paradox still whispers. If the galaxy is old and life is likely, why don't we see it? Maybe intelligent life destroys itself. Maybe it hides. Maybe it looks like nothing we'd recognize. Or maybe civilizations rise and fall in the blink of cosmic time. Maybe they blinked and missed us. There are stars you pass now that are older than Earth. Stars born, lived, and died before our planet even formed. Some have neutron stars spinning in the dark, pulsars flickering like cosmic lighthouses. Others have black holes swallowing light and time. You pass one of those next. A stellar mass black hole, invisible until it bends the light around it. It's not a monster. It's not evil. It's just dense, collapsed. A star that couldn't hold itself up, crushed into a point of infinite gravity. Its event horizon is silent, its pull absolute. You feel it tug you slightly, not enough to fall. Just enough to remember it's there. And around it, debris. A glowing accretion disk, light caught in a spiral of doom. You watch, mesmerized, as matter falls inward, stretched, compressed, incinerated. Some escapes, most doesn't. But even here, near death, there's beauty, and energy, and movement. And still you go on. You pass through stellar bow shocks, great arcs of gas shaped by fast-moving stars. You drift past white dwarfs, the embers of ancient suns. And all the while the galactic background hums, not with sound, but with microwave radiation gamma rays and the deep electromagnetic breath of a galaxy still burning. You're no longer in a solar system, not even in the outskirts. You're in the great engine now. The Milky Way is alive, and you are inside it, tiny, drifting, and impossibly lucky to witness it at all. You're still drifting, still weightless, still swaddled in the endless hum of the Milky Way. But something's changing, not in you, but in space itself. You start to notice that the stars are thinning, the dark is deepening, the glow of the galactic arms begins to fade behind you. You're leaving the city. You've reached the galactic halo, the ancient spherical cloud that surrounds the spiral disk like a faint memory. It's not empty, just quiet, sparse. Sparse in stars, rich in time. The stars you find out here are ancient, old, metal-poor, dim. Many of them belong to globular clusters, tight-packed balls of stars, thousands to hundreds of thousands, strong, orbiting like bees around the galactic hive. These clusters are some of the oldest things in the universe. Some are over 13 billion years old. They formed before galaxies had settled into spirals, before the sun existed, before Earth was even a concept. Scientists still debate how globular clusters formed. Were they the cores of long-dead galaxies? Are they leftover knots from the Milky Way's chaotic youth? Nobody knows for sure. But they're beautiful pinprick galaxies in miniature, held together by gravity and glowing with the dim patience of age. If you could visit one float inside it, it would look like nothing you've ever seen. Stars would crowd your sky in every direction, thousands of them packed so closely that night might never truly fall. You'd see red giants puffing in their final stages, white dwarfs flickering like candle ends, and black holes drifting like sharks between them. But beyond even that, the stars start to vanish. You've reached the true galactic edge where the pull of the Milky Way fades and the intergalactic void begins. You're still bound to the galaxy, but the space between stars is now measured in tens or even hundreds of light years. The distances swell. The silence thickens. Here's a fact that sounds fake, but isn't the space between galaxies is not completely empty. It holds lone stars, intergalactic stars, kicked out during galactic mergers or gravitational slingshots. Homeless, eternal wandering. Imagine being one of those stars, a lone sun drifting for billions of years between galaxies. Its planets, if any, orbiting in endless isolation. It's poetic, it's bleak, it's deeply peaceful, and it leads to a strange realization. You're not even in a galaxy anymore. You're in the intergalactic medium, a realm so vast and lonely it defies emotional logic. The closest galaxy is millions of light years away. The nearest atom may be a meter, maybe 10. The darkness here is pure, untouched. The kind of dark that existed before stars. And yet if you pause, if you wait long enough, you'll see it. A faint haze, a distant cluster, a spiderweb of galaxies glimmering like frost on black velvet. This is the cosmic web. The universe is not just galaxies scattered randomly. It's structured, connected. Galaxies clumped together in filaments and sheets, separated by enormous voids, regions so empty they make interstellar space feel cozy. The structure looks like a neural network or a mycelium map. It's the skeleton of the cosmos. And you're floating in one tiny node of it. The local group. That's our galactic family, the Milky Way Andromeda, the Magellanic Clouds, Triangulum, and dozens of tiny dwarf galaxies, all bound together by mutual gravity, slowly dancing toward eventual merger. One day, billions of years from now, the local group will collapse inward and merge into a single massive elliptical galaxy. But zoom out farther. Farther still. The local group is just one part of the Laniakea supercluster, a vast continent of galaxies stretching over 500 million light-years across. It contains over 100,000 galaxies each with billions of stars, trillions of planets. And Laniakea just a patch in the observable universe. a 93 billion light-year-wide bubble of reality we can see. Beyond it, we don't know. Space may continue forever, or curve, or repeat, or disappear into higher dimensions we can't yet detect. Want a bedtime thought that'll rattle your atoms? The observable universe contains more than 2 trillion galaxies. That's not stars. That's galaxies. Each one a cosmic metropolis of suns, moons, storms, and possibly civilizations. And you live in one suburb of one galaxy, in one thread of one filament, in one web. It's not humbling, it's grounding. You are not alone. You are among. And still the questions linger. Why this structure? Why galaxies? Why not chaos? Why are we here at all? Scientists still debate whether the universe is flat, closed, or open, whether it will expand forever or collapse in a final sigh, whether time has a beginning and an end, or whether it loops like rings in Saturn's shadow. But in this moment, floating in the space between galaxies, the questions don't press. They loosen. They dissolve. The need to understand is replaced by the simple awe of being here at all. Because you are. Somehow, impossibly unbelievably, you are here. Conscious, listening, breathing. In a universe that's 13.8 billion years old, in a galaxy that will eventually die, you emerged for a tiny flicker of time and got to wonder. So drift now, past the halo, past the clusters, past the need to define. You've reached the space beyond meaning, and it is beautiful. You are somewhere now that doesn't have a name. No coordinates, no labels, no constellation charts to guide you. You've left behind the tangled filaments of galaxies, the warm company of stars, the familiar swirl of matter. This is true deep space, the intergalactic dark. And it's not just quiet, it's still. So still, in fact, that the only thing you feel is the slow expansion of the universe itself, stretching the fabric of space like taffy. The galaxies you've left behind aren't just floating, they're moving away from each other, carried by the expansion of space itself. Not flying through space, but pulling space with them. It's not motion through, it's motion of. You're now immersed in the grandest force shaping the cosmos' dark energy. It's invisible, undetectable by any means other than its effect. But it makes up nearly 70% of the universe, and it's speeding everything apart. Galaxies that were once close now recede faster and faster. And this isn't slowing down, it's accelerating. Scientists still debate what dark energy actually is. A property of space itself, a mysterious field, a glitch in our understanding of gravity nobody knows. But it's winning. And it means that billions of years from now, the universe will be a lonelier place. Galaxies will drift beyond each other's light. Civilizations, if any remain, will look up and see nothing. The stars will go out. The night will deepen. And the last embers of warmth will vanish one by one. But not yet. Because even here, far from the galaxies, the universe still holds light. Not starlight, but a soft, ancient glow, the cosmic microwave background. It's everywhere. It's not something you see, but something you exist within. The last whisper of the Big Bang stretched and cooled over 13.8 billion years, now bathing all of space in a uniform chill of 2.7 Kelvin. If you had radio eyes tuned just right, you'd see it all around you, a pale, glowing fog, the same in every direction. This is the universe's baby photo, a snapshot of everything just 380,000 years after it began. Before galaxies, before atoms, before time meant anything. Want a surreal fact? That radiation, those microwaves pass through you every second of your life. They're harmless, but they're ancient, older than Earth, older than the stars. You are a fish forever swimming in an ocean of time. And then, A thought flickers. You turn inward. Because the farther out you go, the more you start to realize you carry the universe inside you. You are made of atoms forged in the bellies of long-dead stars. The calcium in your bones, the iron in your blood, the carbon in your skin, they're not metaphorically stardust. They literally are. You are the product of nuclear fusion, gravity, and time. And so is everything else. The planets, the moons, the atmospheres, the icy bodies in the Kuiper Belt, the rings of Saturn, the storms of Neptune, the heart-shaped glacier on Pluto. Every one of them stitched together from elements birthed in stellar fire. Even your thoughts, the strange electrical dance inside your brain, are running on machinery older than the Earth. Trillions of atoms cooperating for a flicker of awareness, for a chance to wonder about where you are. So here's a different perspective. Maybe space isn't vast because we're small. Maybe we're small so we can hold it all at once. Out here, beyond galaxies, beyond starlight, you start to feel the structure loosen. Reality thins. The questions stop sounding scientific. They become personal. Why does the universe exist at all? Why do the laws of physics work so well? Why can something as small as you even ask? Scientists still debate whether our universe is the only one. Some propose a multiverse, an infinite foam of universes, each with different physical constants, different shapes, different fates. Some are lifeless. Some are chaotic. Some never formed stars. Some collapsed before they could expand. But ours just happened to be right. Balanced, fragile, lucky, not perfect. Just permissive enough for life to exist, and for that life to build telescopes and probes and stories, and to lie awake at night wondering what lies beyond the edge of it all. You float now in something that's not just space but possibility. You imagine what it would be like if you could touch the edge of the universe, if there is an edge. If space loops, if time circles, if the Big Bang was not the beginning but just a local chapter in something far older. You imagine your atoms scattered back into the void, not as loss, but as reunion. And you wonder if somewhere in this darkness there are others drifting too. Other minds, other travelers, listening to the quiet, watching their suns die, sending out songs no one may ever hear. Maybe not today, maybe not ever, but the signal still goes out. Because hope is not always loud. Sometimes it's a whisper in a vacuum. Sometimes it's just a direction. You float no longer asking where you are. You simply are, and that is enough. There is no path anymore. There are no constellations to navigate by, no familiar spirals, no glow from distant galaxies to guide your drift. You've crossed not just distance but meaning. Out here, even time begins to unravel, stretching and slipping through your fingers like dust in zero gravity. Welcome to the timeless edge where physics still ticks, but causality feels thin. You are far beyond the stars now, beyond even the idea of structure. The space around you doesn't hum. It waits. You're not in the void. You are the void. But void doesn't mean lifeless. Because this far out, what you feel isn't absence, it's potential. A blank page. A silence that isn't empty but listening. Space itself is a field, a canvas awaiting breath. And something is still happening. It's subtle. It's everywhere. It's called quantum fluctuation, a jitter, a twitch, an unsteady hand at the bottom of the universe. Even in the coldest vacuum, particles still flicker into and out of existence. Virtual pairs of matter and antimatter born and annihilated before they can be seen. It's like the universe never truly stops whispering to itself. Scientists still debate whether these fluctuations were the spark that ignited the Big Bang. Whether a tiny patch of space puffed up by inflation created all we know from essentially nothing. That nothing, by the way, isn't what you think. It's not zero. It's not absence. It's unstable. Give it the right conditions, and it erupts. Into time, into mass, into stars and atoms, and eventually, you, the strange implication. This entire universe might have been a quantum burp, and from that everything. You floating here. The stars you've seen. The ancient light in your eyes. All born from fluctuations in a void that doesn't look that different from where you are now. That's the loop. That's the full circle. You've left the solar system. Left the galaxy. Drifted beyond structure into a place that feels like a mirror of the beginning. You've traveled outward, and now you find yourself staring in. Because at this point where direction is meaningless, the next question isn't where am I, it's what am I? You are consciousness, wrapped in atoms, housed in biology, driven by wonder. The universe has spent 13.8 billion years becoming complex enough to produce one single moment of why that moment is you. Maybe you're made from star stuff, but you're also made of questions. You drift in a reality so vast, no one will ever map it completely. And yet, you've been able to comprehend it. Not just the parts we've visited, but the possibilities still unfolding: dark energy, multiverses, cosmic cycles, birth, death, heat, silence. All of it dancing through the theater of your brain like shadow puppets flickering against the walls of imagination. Want something useless but unforgettable. If you stretched your arms as wide as the universe, the thickness of a single sheet of paper would represent the entirety of the observable cosmos. That's how thin this experience really is. And yet it feels like everything. There's another theory, wild debated, poetic, that the universe is holographic. That everything we experience in 3 dimensions is encoded on a 2-dimensional boundary we cannot see. Like a projection. Like a dream. It's not proven, but it's not impossible. And if that's true, if all you are is a flickering pattern on the edge of something else, does it matter? You're here after all. Breathing. Imagining. Drifting. Reality doesn't have to be solid to be beautiful. It just has to be shared. And even if you are alone right now, adrift in mental space or physical space or somewhere in between, you're part of a long, quiet tradition, the tradition of wondering. You share that with early humans watching the stars from caves, with astronauts watching Earth rise over the moon, with scientists watching faint signals on radio dishes, with artists, dreamers, poets. With every child who ever asked, "What's past the edge?" You're part of that. And maybe that's all the meaning you need. So now as you drift, you close your eyes not because it's dark, but because you don't need sight to feel this. The weight of it, the smallness, the immensity, the strange comfort of knowing that the universe doesn't owe you answers, and yet it gave you the curiosity to ask anyway. Behind you is every planet, every moon, every spinning storm and dusty ring. Before you is the unknown. And that's not scary anymore. That's the whole point. You feel yourself slow, as if the universe itself is taking a breath alongside you. Time stretches and softens, no longer a relentless forward march, but a gentle tide pulling you deeper into quietude. Behind you, the solar system's fiery heart, its spinning worlds, the storms and secrets of planets past, all become a hazy glow fading into memory. The endless dance of matter and energy begins to blur, the sharp edges rounding off into a soft focus dreamscape. Out here in the great cosmic dark, the complexity of existence distills into its simplest form: being. There is no need to know, no need to understand. The questions you carried shrink to whispers, and the weight of wonder becomes a lullaby. You breathe slowly now. Feel the ancient atoms in your body forged in stars long dead, carrying stories older than Earth, older than time as you know it. You are a thread woven into the fabric of the cosmos, a spark of consciousness adrift on the sea of infinity. Scientists still debate the ultimate fate of the universe. Will it expand forever into cold oblivion, collapse back into a fiery rebirth, or rip apart in a catastrophic Big Rip? None of these futures matter here. Not yet. Tonight the universe is calm, holding you gently in its vast, unending arms. And as your eyes grow heavy, the vastness doesn't overwhelm. It comforts. It sings a song older than any star, a song of quiet persistence, of endless becoming. In this moment, you are home. The journey you took tonight from the blazing sun to the furthest reaches beyond galaxies was never really about distance. It was about presence, about belonging, about seeing yourself reflected in the great cosmic mirror. Now let the stars fade into sleep's embrace. Let the universe fold softly around your dreams. You are part of everything, and everything is part of you. Good night.